All right, so today we are doing scatter plots. We just got this data over on the sideboard there. It's written up there, so you can start doing that. We are going to make a scatter plot on this graph. So based on that data that we just had. So if you're not in class, we just threw stuff at a wall. Here are the ordered pairs we had. 7, 7, 8, 3. You don't need to write them down if you're in class. I'm doing it for the people at home. 6, 3. 12, 3. Yeah, you could start graphing those on as X, Y. So 12, 3. 16, 3. 14, 5. Very exciting to watch me write down numbers. 8, 4. 13, 10. 12, 8. And then 11, 5. Okay, so all we're doing is making a very basic graph here. Down below, these are going to be my X values. So 2, 4, 6, 8, 10, 12, 14. That's 16. My Y values. All right, so then we're just plotting 8, 4, and so on. I'm going to hit pause so you don't have to watch me do this. All right, so we plotted these points. It's supposed to be scatter plots, and when we make scatter plots, we are often going to make best fit lines. Does this data look linear? Does it look like a line? No, it does not look like a line at all. I would say it very much looks not like a line. But we need to make a best fit line, so that's what we're trying to do today. We're trying to make this data linear. So what we're going to do is use a straight edge of some sort, whether it's your ID or the side of your cell phone or your calculator or whatever you got around, but we're going to draw a best fit line. Okay, when we draw a best fit line, our job here is to try to balance as much data above and below and to go in the general direction of the data. And so for me, as I look at this, how does that look?
Pretty good.
Not bad. Maybe, I don't know. There's some dots up above it that are kind of pulling me up. I'd really like to make it a little bit more, a less steep slope, maybe, just because a lot of those dots are going down, but those other ones up on top are pulling me up. So I'm going to try one more time. Man, that's rough, but that's what I got. Okay, you are drawing something for you. Okay, you are not going to try to draw the exact same line as me. You're drawing the one that fits you. Okay, so draw your best fit line. Once you draw your best fit line, we are trying to write a prediction equation. Okay, so when we say a prediction equation, that is an equation of a line. If I want to write the equation of a line, what do I need? 2 points. I need a slope. And so I'm looking at this graph that I just made, and I'm trying to find an intersection spot. So where does my red line cross the grid? And so, like, right there is not bad. So what is that? 3, 3. Looks like a dot I crossed. So I'm using 3, 3 as one of my points. You got to find another one. You want to find your other one significant as far away from that first one as you can. Just that way it doesn't mess up my data. I'm going to use this point right here, even though it's not perfect, just because it's far away from my data. But 15, 6. All right, so I got my 2 ordered pairs. Once I have my 2 ordered pairs, I'm going to find the slope. So y sub 2 minus y sub 1 over x sub 2 minus x sub 1. 6 minus 3 is 3. 15 minus 3 is 12. 3 divided by 12 is 1/4. Find your slope based off of your graph. What is a slope that somebody else found? I found 1/4. So 5/13. Sai, what'd you get? 2/5. Somebody find something else? 5/11. Everybody somewhere in that ballpark? You might be off a little bit some way or the other. We are doing this by hand. This is very much subjective to us. We're not that good at this. Okay, it's going to be subjective. That's okay. That's why we're going to use our calculator here in a second. But we found 1/4. Now we're going to write the equation of a line. So if we're writing an equation of a line, we're going to do it in point slope form. So y minus and x minus. I'm going to plug in my ordered pair, so 3, 3. I'm going to plug in my slope. It's 1/4. I'm going to show you a trick I teach like algebra 1 kids that struggle with fractions. Do it normal if you do it with normal. But if you have point slope and you're trying to get it into slope intercept form, one thing you can do is distribute the top of that fraction to the right and the bottom of the fraction to the left. It's kind of cheating, but what we're doing here is not dealing with the fraction until the very end. So I get 4y minus 12 equals x minus 3. Then I'm going to add 12 and then divide by 4. Y equals 1/4 x plus 9/4. You do not have to do it that way, but it's a little helpful method there when you're writing in point slope form to try to not deal with the crazy fractions. Questions to there? Write the equation of your line if you haven't yet. Great. We found the equation of our best fit line. Our job is to figure out how far away would you be if you threw from 20 feet. So I'm giving you the number 20. The furthest we threw was 16 feet. If we extrapolated that to 20 feet, how could I predict how far I'm going to be away from at 20 feet? Plug it in. Good answer. I'm glad we all said it at the same time. Y equals 1/4. We're just plugging 20 in there for x into your equation. So take out your calculator and figure out what you get when you plug in 20 into your equation. So for me, I'm going 1/4 times 20 plus 9/4. Type it in, hit enter. I get 7.25 is my distance. Somebody get something else? What other distance away from the center did you get? 7.42. Lily, what'd you get? 6.77. Okay, 6.77. Jared? 8.17. Everybody somewhere between like 6 and 12?
Yes.
Yeah? All right, so we're close. But we're still pretty far away. We weren't really that close. When you think of the number 6 and you can go all the way to 12, it's quite a bit different. All right, so we want to be a little more accurate than just being close. We want to be correct. Okay, so now we're going to use our graphing calculator. So please pull out your graphing calculator. Let's do some data. All right, so just to clear some things up, I'm going to hit my y equals button. If you got some equations in there, I'm going to clear them out just to save me some hassle later on. There is one thing you have to do first that's probably not true on your calculator that we don't have to do again, but you have to do it the first time we do it. So you need to hit second catalog. Okay, so second and the number 0. Second catalog. And we want to pick diagnostic on. Okay, so this is in alphabetical order, so I'm going to go down to D and go down to diagnostic on. What this is going to do is it's going to tell me your R squared value. If you remember from AP Stats, it's going to let you know what your R squared value is, and we'll see what that looks like here in a little bit. So diagnostic on, I'm going to hit enter. It's going to say done. Everybody good to that point? So again, I hit second and the number 0. It's going to get you catalog. I went down to diagnostic on. I turned it on. I hit enter, It says done. Great. Once we've done that, we're going to type in our data. So now you're going to hit the stat button. We're going to go to number 1, which is edit. And your screen should look like this. If you happen to have some data, like if I had like a 3 and a 2 and some other stuff, just go up to the top to L1 and hit clear. Don't hit delete, because if you hit delete, you messed everything up. Hit clear, hit enter. It'll clear out my data. So now we're going to use that same data we used to make our own chart, but we're going to put it into our calculator. So right now, you're typing in your X values is L1, your Y values is L2. Type it in. Go. All right, so we typed in all that data. If you're at home, just hit pause on the YouTube video so you can type in those numbers. But once we've typed that in, okay, the next thing we're going to do is graph it. So we're going to hit the Y equals button real quick. And this is something else you have to do or this won't work. We need to turn plot 1 on. So we want to look at data. If we want to look on data, we got to turn plot 1 on. So take your cursor, go up to plot 1 right there and hit enter. It should be bolded. Okay, if you're not doing data, you do not want plot 1 on. A lot of students then later on will be like, I can't graph anymore. It's because plot 1 was on. Okay, so turn that off if you don't need it, but we need it right now. The next thing we're going to do is we're going to hit the zoom button. Okay, the zoom button's right there in the top in the middle. And once we hit zoom, which one of those zooms do we want if we want to look at statistical data? 9. We're going down to zoom 9. So I'm going to go down here to zoom number 9, zoom stat, hit enter. There are my dots. Okay, that's the same thing that we did by hand a little bit ago. Those are the same dots, just a little bit different graph. Questions there? Does that one dot look weird? No, that's fine. Okay, it just looked weird to me. Cool, we've got that. The next thing we're going to write is the equation of the line. Okay, so we did this by hand earlier, but now we're going to do it with our calculator. So now we're going to hit the stat button, and we're going to go over to calculate. So hit the over button there. So we go to calc, and we're writing an equation of a line. We're doing a linear regression. So I'm looking down here at number 4. Number 8, I know you use that in stat class. We're going to use number 4, okay, because it's in the form y equals mx plus b. So I go down to number 4. I'm going to hit enter. Now pay attention to this. This might be a little bit different. I'm going L1, great. L2, great. Frequency list, we don't mess with that. But the store regression equation, we want to store this. That way when we hit graph here in a minute, it'll graph it for us. And so here's how we're going to do that. You can hit alpha. So right there, the alpha button, the green button, and then F4. Alpha, F4. So the trace button. Alpha and then trace, or alpha and then F4. And what that does is it allows us to pick Y1 really easily. And I'm going to hit enter for Y1. So what we're going to do is we're going to write the equation line, and then it's going to save it in my calculator as Y1. That way I don't have to retype it in. Down to calculate, hit enter. There's my regression line. All right, so let's look at some things. What was the slope of my regression line? Yeah, 0.125. I think my slope was the least steep, and it was 1/4. So it's half of what I had. All right, so it was really small steep, or really shallow depth. Whatever, I'm making all those words up. The one thing that we want to look at this is the R squared value. Look at your R squared. We got that by turning diagnostic on. If you didn't turn diagnostic on, you won't see that. But my R squared is 0.028. That number right there is a handy number that will tell you how good is your data. Here is the chart on your notes about that. We got 0.028. How good was our data? How strong of a correlation does it have? Very weak. We are terrible. What we just did really doesn't apply to anything. It's a very weak correlation. It's almost like a random cluster of dots at that point. There was really nothing connecting the two of them. Okay? I've never seen one that low. It's incredible what we just did there. All right? But it's really far off from what we wanted. All right, so this is not a good way to do this. This is just telling us that our data doesn't really do much for us. It's not very strong correlation. Okay, but great, we've got it. Let's go second quit. Let's do one more thing. Okay, so again, we can hit the graph button. Hit the graph button real quick just so you see it. There's our best fit line. It's in the middle of your data. It touches one dot. It's not a good sign. Okay, it's not really in the middle of anything, or it's not really touching anything. So we can see it. If you hit your Y1 button, you could see that equation. It typed in the slope and the y-intercept without rounding anything. So that's what we just did with that by storing the regression line. I'm going to go second quit and get back to my regular screen. Now let's plug in 20. There's different ways of doing it. I think this is the best way. Okay, if you want to plug in 20 here, I'm going to go alpha, F4 again. So I'm going to pick this menu. I'm going to pick Y1. And then in parentheses, I'm going to type 20. Think of this as like doing f of 2. If you do f of 2, it means take 2 and plug it into the f equation. By doing y1 parentheses 20, it's like saying take 20 and plug it into your y1 equation. You hit enter. How far are we from the middle of the target? 6.266. So I think I had 7. Some of you had 6. We're in the right ballpark. Kind of makes sense what we're doing there? Super. All right. Here's what I want you to do. Try the next one. So down below, you've got some data on how much school you go to and how much you make in your lifetime. Type that into your calculator. Find the regression line. Answer those questions. See what you can do. Go. Just an FYI, there's a video right there on your notes, that QR code. That takes you to me going through this again. So if you need to see me walk it through again, if you're not great at this, it's there for you. Okay, but this is the second time through it. So we went stat, we went edit, we typed in our data. Once we've done that, we want to look at our data. So we're going to hit zoom. Which zoom are we using here? 9. So zoom's right in the middle. There you go. And then the number 9 because we're going down to zoom stat. So I still have my line drawn from before. That's what's in the weird corner. But look at that data. This data, does it look like a line this time? Yeah, it's much more linear. Okay, so great. Once we've done that, we're going to go stat and then over to calculate. So over 1 to calculate. And we're going down to number 4, which is linear regression. Okay, we're right here. X1 or L1 is great. L2 is great. We're going to go down to store regression equation. Where it says store regression equation, we hit alpha F4. And then we're going to pick Y1 because we want to save that first equation. We want to save this equation as Y1. We go down to calculate. We hit enter. And we should get this right here. Again, if your R squared value is not coming up, then you're not, you didn't have your diagnostic on. My R squared value this time is 0.86. Well, let's write down the equation first. So write down our equation because it asks for that. How many decimals should I round to? 3 always. Good answer. Yeah, I'm glad we always said 3 every time we round in this class unless I tell you otherwise. Y equals 0.287x because that's my slope, 0.287. And then my y-intercept is negative 1.984. Cool. That's my equation. What type of correlation does this have? So to talk about that, that's our R squared value. Our R squared value this time is 0.86. Where does 0.86 fall into our chart here? Strong. We're pretty good. The closer to 1, the better. Okay. If your R squared is 1, you're great. 0.86, that's pretty strong. What kind? And we did linear. Okay. We chose the regression, linear regression. So what type of correlation does it have? It has strong, linear. Oh, yeah, that's fancy. Strong linear regression. But good to that point. Last one says, what if someone received a double doctorate? Or in other words, they went to school for 26 years. What would you estimate their lifetime earnings to be? How do we estimate how much money they would make? Plug in. Okay, we could just take it and plug it into that equation because we have it. But let your calculator do the work. And so remember from here, second quit, we get back to our regular screen. And we want to plug it in. Okay, so William, to do that, we're going back to the screen. Alpha F4. Pick Y1. And we're going to plug in just like F of 2. You would go F parentheses 2. We're doing Y sub 1. And we're going to plug in 26. Yeah. So parentheses 26. Hit enter. $5.477 million. Does that make sense? Will this continue to work forever? No, why not? Kobe. Extrapolation. Eventually, we're working outside of the numbers we know. If you were to go to school for 84 years, are you going to make millions of dollars? No, you're probably negative dollars out there, and you're not going to be very happy. Okay, so don't extrapolate the data beyond that too much, or otherwise it's not going to work. Okay, this is not on your paper. You're just looking at the screen. Okay, just some real quick. What do you know here? Okay, not on your paper. You're just looking at my screen up here. So different levels of correlation. You can have positive correlation. You can have negative. Why do you think this graph right here is considered positive correlation? It's going up. Okay, that one is pretty strong correlation. It's really easy to draw. This one is moderate. They're not quite as close. That one is pretty weak. They're more scattered. Okay, same thing here. We've got negative slope, negative slope, negative slope, so it's negative correlation. It just depends on how tight of a correlation data it is. Okay, we could have no correlation if it's just a bunch of dots randomly, no correlation. Linear versus nonlinear. Looking at that first one, does it make sense that you would draw a line with that data? Yeah. Then it's a linear correlation. Okay, the next graph is nonlinear correlation because it's pretty easy to see that it would probably not be best to draw a straight line. This data is more doing that. It is more modeled by a bent line, a nonlinear line. Make sense? All right, so based off of this graph, I've got graphs 1, 2, 3, and 4. Which one of those up there, 1, 2, 3, or 4, is the best representation of nonlinear data? Show me the fingers. 1, 2, 3, 4. 2. I agree. On 2, it would look like that. Would that be positive or negative correlation? Negative. It's definitely going down. Which example up there is the best representation of positive linear correlation? The best example of positive linear correlation, I agree, that would be 3. Which one of those graphs up there would be the best example of no correlation? 4. Number 4, is 4 positive or negative correlation?
Negative.
Yeah, maybe, but I could even, maybe it goes that way. It's just bad. It's just not a very good graph in terms of being able to make that decision. All right, so flip your paper over to the backside. On the backside, we've got 4 graphs. 1, 2, 3, and 4. Let's play that game again. Show me with your fingers which one of those is the best representation of strong correlation. 1, 2, 3, or 4. Which one's the strongest correlation? I would agree. You're saying 4 is the strongest. Which one would you say is the weakest correlation? 1, I agree, is the weakest correlation. 2 or 3, which one do you think is stronger between 2 or 3? Yep, I would say 2 would be second. So I'm going to call it just strong instead of strongest. Which one of the, if you had to pick one for nonlinear? Yeah, maybe 3. Yeah, that's a mean question. I don't know if any of them are necessarily nonlinear. I could see 3, but I could see 2 kind of doing that a little bit too. But that's the main idea. Make sense on where we're getting that from this? All right. So for tonight, you're going to practice this. It's more of just practicing. It's not a hard thing we learned today. It's just, hey, can you hit the buttons? Okay. So you've got one more example down here. This is McDonald's nutrition facts. You've got total fat per item and total calories. Okay. I'm going to make it a little bit easier on you. There's a graph. You do not have to graph anything by hand. Okay. Graphing by hand is a great skill, but it's not very scientific. I'd rather you be able to use your graphing calculator. So you're not going to graph it by hand. So number 1, you don't have to do. Number 2, you're going to describe the correlation. Number 3, you're going to graph the best fit line on your calculator. Number 4, you're going to find the linear model. And number 5, you're going to predict how much calories would be in a 19 gram. And then number 6 is interpret the slope. Make sense on what you're doing this evening? Just practicing the same thing we've done. Okay? See what you can do with that. We'll go over that tomorrow and move on to our next section.